Hi, this is Ben from Fixitgearware Security, and we're here with another episode of Coding Thursday with Fixitgearware. In today's episode, we are diving into C programming by first discussing a few concepts, which involves how to be able to write any program or tool, and breaking it down further by describing a few methodologies and approach in building effective tools and readable codes in cybersecurity. So without wasting much of your time, shall we dive into today's episode? Introduction to C programming. To be able to code or write any program or tool, you must adopt these three concepts. They are top-down analysis, to reduce complexity and understand fully what the code is all about. The top-down analysis also helps in minimizing complexities and understanding the flow of the program. It further demonstrates how the code of the tool should flow and ensuring the simplification of the process. So, in any programming language you decide to write or code your tool in, be it C, C++, PHP, Java, Python, Bash, and so on. To clearly understand your program and make it readable for others, the top-down approach should be the first go-to concept you should make reference to before coding your tool or writing your program. The next point is the modular programming. The codes are written to be logically independent and has a unique name. So basically, for modular programming, let's say you have a function in a model. You have to understand which code is to be executed first before calling the function or the model. The essence of modular programming is to ensure the code in the program are broken into smaller files of functions or models, and then these files are imported in the other programs when needed. One of the benefits of modular programming is that it makes it easy to trace errors in your codes when you're trying to debug them. This will be demonstrating in our paid courses on programming when we publish them. The third point to be able to code or write any program or tool you must adopt is the structured code. Structured programming describes a good control flow and must consider both the top-down analysis and modular programming approach first before being able to write a structured code. Let's consider an example to this approach by using a database analogy. For instance, when you visit a website of a certain service provider to conduct some registration on their website or portal, certain information will be requested from you, which include your username, your address, your first name, your middle name, and your surname. So to be able to have an understanding of the entire registration process, let's start by analyzing the structure of their web program or application. Considering you are required to provide specific data and submit a form on their website, the data must be accurately processed before being registered. For this data to be successfully registered, the back end of the web application must follow a series of steps. This involves the database using my SQLite connection or any other database connection to connect to the database. But before the connection is established, an error check of credentials are conducted, such as database server name, the username, and password of the database. This implies the database checking for connection error or check for success in connection of the credentials supplied in the prepared statement. Speaking of prepared statement, the importance of prepared statements will be discussed in our further advanced pen testing paid courses in SQL injection. After these checks have been successfully conducted and connections established, the code then proceeds to check for fillable data provided in the form to ensure the necessary fields required have been met. This also follows a back-end structure of the code. If all the requirements have been satisfied, the form then proceeds to create or insert these data provided into the database. This is how a good structure of a program should be. Also, referencing this example to the first two concepts described earlier on. Firstly, the top-down analysis. For the top-down analysis, we can discover in the entire example of the description of check for errors or success in the database credentials supplied. Under the modular programming, referencing the example given, we can notice that the entire data creation involves a series of processes, and writing the code of the entire process in a file could result into the program crashing, being unreadable, or inability to be debugged in the eventuality of code error. Hence, the code which establishes the database connection and check for errors is written in different functions or file model, and the one responsible for passing the data to the database is also written in a separate model. This makes it not just easy to read the program, but also establish a control flow. So although this whole description is about programming, also a pen tester or bug bounty hunter who understands a good control flow of a program can deduce how to hack or break the program as well. We call it the framework of building a good tool or software program in cybersecurity at Fixitgearware Security. So understanding this concept further, let's break it down to a more simpler form. For an effective top-down approach, a cybersecurity tool developer must understand and classify them based on 1. Subdivision of a problem, 2. Hierarchy of tasks. This method of hierarchy mirrors the risk assessment classification based on criteria, which is the likelihood of occurrence and the impact on the organization. In terms of hierarchy, you have to structure your code using the top-down analysis on what comes first, by what follows next, and what comes last. The second part of the program is the modular programming. An efficient modular programming approach must have series of programming instructions. It must have a unique name, one entry, an exit point from which control is returned to the model. For structured code, for an effective structured code to be attained, it must reference to the top-down and modular approach first. Then secondly, it ensures that the control flow is not broken. So for instance, when you're writing a code, you do not want the control flow to not be in a sequential manner. If function A is to be called first, then function A has to run or be executed first before function B is executed. The program is not structurally designed, or the codes are not properly structured. This might result into the code breaking, and the function of the code might not be effective. So instead of having a proper tool that carries out the function or the purpose it was designed for, you find a tool that is slow or not even giving the output of the expected outcome. So let's have a visual presentation of this by writing a simple basic program of even numbers and then converting it into a structured program, so you can have a proper understanding of what we are actually doing. Let's list an even number. As we know, even numbers are numbers divisible by 2. So for example, we have it to be 2, 4, 6, 8, 10, 12, 14, and 16. The next thing we want to do right now, let's write the basic code or the basic programming, and we're going to convert this into a structured programming. Before we write the code, let's write the series of steps we want the code to take. Let's say maybe it's going to take 9 to 10 steps. Let's just list depending on what we want to do with the code. Let's just go with 9 first for now. As the steps increase, we'll be adding more. 6, 7, 8, 9. Okay, so first let's say input X. So we are going to get a value from the user of the system or application. So the next thing we want to check is if X over 2 is not equal to even, then we say go to. The next step we want to do is we want to do a series of control flow programs. We can say, okay, Q equals to X times 2, and we can say Q1 equals to Q plus 2. Then we can come again and we say Q2 So it'll be equals to Q1 plus Q2. Then let's introduce another last code. Let's say Q3 equals to, let's say Q, okay, we made a mistake. Going back to line 5, there was a mistake. We'll say Q2 equals to Q1 plus, let's just call it X. Then we'll say Q3 equals to Q1 plus Q2. So if we check this program again right now, we have input X. If X is not equals to even, go to, we have introduced a control statement here. We set Q equals to X times 2. So the value of X multiplied by 2 is the first control here. Then we move on to step 4. We set Q1 equals to Q plus 2. So the value we got from step 3, we should add 2 to it to get Q1. And in step 5, the value of Q2 is equals to the value we got from Q1 plus the value of X, which is whatever the person supplied in the input if it passed the test. Now we can decide to introduce an equation here. We can say, okay, if the square root of Q3, let's call this, if the square root of Q3 is not equal to even, go to. Then for the step 8, we can say print Q3. Then for step 9, we can say invalid input. And for step 10, exit or end. Now, let's understand the whole structure of this basic program. So first of all, we declared our even numbers, which is 2, 4, 6, 8, 10, 12, 14, 16. The numbers declared, as we know, are divisible by 2. Then the first action the program needs to take is to receive an input from the user. Then after receiving the input, it checks for the input if it's divisible by 2 or not. If it's not equal to even number, then we say it should go to step 9. We can now say go to step 9, which means invalid input. However, if this stage is passed or the check for this stage is successful, it proceeds to step 3. It runs the first command, which is the value of X multiplied by 2. Then it moves on to the next control flow, which is Q1, which is the value of Q plus 2. Then it moves on to the next step, which is Q2 equals the value of Q1 plus X. And it moves on to the next step, which is Q3, which is equals to the value of Q1 plus Q2. Then at stage 7, we said if the square root of the value of Q3 is not an even number, then it should go to where? Now, where did we have a value that did computational values that we check for Q3? So if you look at Q3, Q3 has to do with Q1 and Q2. And Q2 has to do with Q1 plus X. And Q1 has to do with Q plus 2. So we say go to step 3, where the whole computational process started from, to be able to get a number that its square root is an even number. Then if we finally got a number that its square root is an even number, the control flow will print the value of Q3, and 9 is invalid input, which is referenced from step 2 if the number is not even. And of course, after printing the value of Q3, the program successfully ends. So this is a simple basic program. And if you look at this whole program, the point or framework we described was properly implemented in this code. First is the top-down analysis, which is of course starting with the input down to where the program ends. Then the modular programming, which of course each has its own function. Like you see, Q1 has its own function, Q2 has its own function, Q3, and so on. But the third part, the structured programming, is not yet described, which of course we'll be referencing this code back into a structured programming. It's a simple basic program describing the first 2 points, which of course is essential so you'll be able to understand the whole concept of what we are describing. Now, let's now convert this basic code into a structural programming. So the first thing we want to do is, for structured programming, we can say input x, right? Then the next thing we want to do is, if we use goto, it's going to be a problem. Means for structured programming, the code will just be going through the sequence. However, exception of goto in structured programming is when you know that it's inevitable. If it's avoidable, you should not use a goto statement in a structured programming. So for this structured programming right now, let's write structured programming. The first thing we want to do is to receive an input from the user, right? Input x. Now, if we use a goto, it's going to be a problem. Means the program has to follow this sequence. So we can say while x over 2 is equals to even number, then the whole code here should be executed. So basically what we are trying to say is that while x over 2 gives us an even number, then it should run all this other sequence, which is this. Let's copy this and paste here. Then after that, it should now check for the square root of Q3. Then it should now print Q3. Okay, print F Q3. Let's remove this. Let's remove this so you can have a proper understanding of what we are doing. And print this. Else print F invalid input. Then end. So if you look at the structured programming right now, it's very simple compared to this. For the basic, we got an input, then check if it's divisible by 2. If it's not, then it should go to 9 to this. If it is, then it will start executing this. If you apply this concept in a structured programming, definitely your codes are going to have errors. You'll be finding it difficult to pinpoint where the issues are or debugging the error in the code. So for structured programming, the first step we did is receiving an input x from the user. Then we specify that while x divided by 2 is equals to even number, then it should proceed to execute the following codes, which are q equals to x multiplied by 2, q1 equals to q plus 2, q2 equals to q1 plus x, q3 equals to q1 plus q2, the square root of q3, then print q3, then end the program. Else, if it's not this, it should print this invalid input. So the reason why we use while statement in this program is that in programming, while represents repetitive execution. So as long as the conditions are met or the criteria are satisfied, then the code should continue running in this sequence. However, if they are not met, then the program should terminate. This is how you should understand structured programming in a very good concept. And if you look at it, you can see that we implement the other two concepts earlier described, which is the top-down analysis. You can see from here, the first thing it has to do is to receive input from user. Then the next is to check. Then here it's control flow, which is modular approach. And of course, print, then end. Basically, the three concepts of programming or developing a tool has been described here. So when you understand this whole concept and all this approach, you'll be able to build not just a scalable tool or application if you're a software developer, but you can also be able to debug or trace back the problem of your code when they arise. So that's it for this week. We have come to an end of this week's episode, and we hope you have learned something new. Please do not forget to give us a like by pressing the thumbs up button, subscribe by tapping that subscribe button, turn on notification bell by clicking that bell icon to be the first to get notified when we publish our next video. Also, we, the entire team at Fixitgearware Security, are using this medium to wish you and your entire household a wonderful Easter celebration. Thanks for watching, and see you next week, Thursday, on another episode of How to Code with Fixitgearware Security. Bye for now.